we shall see about substitution nucleophilic internal, that is SNi reaction and elimination reactions of alkyl halides. Actually, SNi reaction will take place in alcohols, the preparation of alkyl halides, and some reactions of alkyl halides, that is elimination reaction. These two we'll see in this video. In our previous video, we have seen about SN1 and SN2 reactions. In the case of SN1 reaction, it is a single step reaction which takes place via the formation of a carbocation, and then the product is formed, and the product will be racemization. We are getting both types of products, D isomer and L isomer. In the case of SN2 reaction, the reaction takes place by a front attack, back attack, which involves in the inversion of configuration, and this reaction takes place in a concerted way, that is in a single step mechanism. Now in this video we shall see about nucleophilic substitution reaction, which follows second order kinetics, that is it takes place in two steps and it follows second order kinetics, and this reaction, the product will be retention of configuration, a different one. And what happens is, here the attack is an internal attack which is also a front attack. Now we shall see this some SNi reaction, that is substitution nucleophilic internal. Okay, see this example, this one, this is substrate, this alcohol, substrate alcohol which is a chiral alcohol. See the reaction with the thionyl chloride, and in the presence of ether, the solvent will be ether. The product what we are getting is a chloro compound, substituted chloro compound, and here the stereochemistry is retention of configuration. You have started with D isomer and the product is also will be a D isomer. If you start with an L isomer, then the product will also be an L isomer. See this in mechanism. We see the mechanism. What happens in the first step, this thionyl chloride and the alcohol reacts, and this oxygen being highly electronegative, it withdraws the sulfur, it attracts sulfur, or we can say sulfur being highly electrophile because of the presence of two chlorine atoms and one oxygen atom, it becomes it acts as an electrophile, and so it is ready to accept two electrons. And what happens is the reaction between alcohol and thionyl chloride takes place in the presence of ether, and this step is the slow step which is called as the rate determining step. And in this step, see what happens is this sulfur is attached to oxygen, so that sulfur carries a positive charge, oxygen carries a positive charge. And what happens next step, the sulfur is the sulfur dioxide, this chloride ion is removed. This chloride ion is removed, and so this product is formed, and this will be chlorosulfite ester. Chloride ion is removed, and then the H plus ion is removed. You can see the mechanism, and what happens, the product is chlorosulfite ester, or it is also called as alkyl chlorosulfate. This alkyl chlorosulfate is first formed by a slow mechanism, slow reaction, and this is the rate determining step. Since chiral alcohol and thionyl chloride are involved in the rate determining step, then it is called, then this reaction is called as a second order reaction. And now coming to this chlorosulfate ester, now what happens is in the second step, this chlorosulfate ester breaks from that of the carbon, so that it forming a chlorosulfate anion and a cation called carbocation. So this carbocation and this chlorosulfate anion makes an intimate ion pair within the solvent cage. They are very close. Intimate means they are becoming very very close, and so we cannot separate them both the cells because they are bound in a solvent cage. And what happens, then sulfur dioxide is removed, and this chlorine bounds to this new ion, they forms a new ion pair, so that the carbocation and the chloride ion forms a new ion pair, which is also an intimate ion pair, and sulfur dioxide alone is removed, and they are also inside the solvent cage. And in the last step, what we get is this chloride will attack this carbocation, forming the compound chiral chloride with retention of configuration. So if you are starting with the D isomer, the product will also be a D isomer. This is the mechanism of SNi reaction, and here you can say I'll show that some more point. The overall reaction is considered as an internal attack. See, you can see the mechanism, how that is chlorine is attacking in the front side, through the front side, and so see this chloride ion move to this position and the sulfur dioxide is removed, and so what happens is that we are getting the product with retention of configuration. So this reaction is called as SNi reaction, that is substitution nucleophilic internal. It's because the reaction takes place within the molecule, the attack is within the molecule, and so it is called as the name internal SNi mechanism. Okay, this is a reaction for preparation of alkyl halides. Now we'll move to a reaction. Elimination reactions of alkyl halides. Here what is meant by elimination? Elimination means removing a molecule or groups from a molecule is called as elimination reaction. See, here it is the reaction given here is a dehydrohalogenation reaction. See, what has happened is the halide ion is removed in the presence of a base, and then one hydrogen is removed from the nearest carbon, so that what we are getting is a double bond. So we are converting a saturated compound to an unsaturated compound. This is called as an elimination reaction. Now see this one. Now coming to elimination reactions, there are two types of elimination reactions. See, this reaction I have shown again. A double bond is formed between two carbons, a new double bond is formed. So conversion of a single bond, sigma bond, to a pi bond. Okay, so sigma bond plus pi bond is formed. Okay. And now there are two important elimination reactions. One is E1 and other is E2. First we shall see E2 reaction, which is a concerted reaction and which takes place in it takes place in a single step, and the order is second order kinetics. So E stands for elimination and 2 stands for bimolecular. So it is bimolecular elimination reaction. Here the example I have taken is tertiary butyl bromide, and in the presence of a strong base, the reaction taking place in the presence of a strong base. So what happens? A hydrogen, this halide ion, and the hydrogen ion from the beta carbon is removed, and so we get 2-methyl propene, and the product, this water is product, and the bromide ion is given out. This is an example for E2 reaction. Coming to the second kinetics, the reaction depends on the concentration of both the halide and the base. That must be a strong base. So the reaction rate depends on both the halides and both the substrate and the base, and so it is called as a second order reaction. Now coming to the mechanism, see the mechanism. This proton abstracts this H plus. Since it is a strong base, this base abstracts this proton is removed, and this bromide ion is eliminated, and this is the product. I'll show this one. See, the base is removing a proton from the beta carbon, and the halide ion is removed from the alpha carbon. So this is the mechanism, and here since the nearest two carbon atoms or the vicinal carbons are involved in the reaction, it is called as a 1,2 elimination, or it is called beta elimination reaction. So E2 mechanism can also be called as beta elimination, because beta hydrogen is removed and alpha halide ion is removed, and this reaction is dehydrohalogenation, or it is also called as 1,2 elimination reaction. Now this is E2 reaction, and now we'll move to E1 reaction. In case of E1 reaction, here the reaction takes place in 2 steps, and here the elimination reaction, here the reaction involves only on the concentration of the alkyl halide, and so it is called as first order elimination reaction, because it depends on the concentration of the alkyl halide. Here I have taken the example tertiary butyl bromide. Here instead of a strong base, we are taking a weak base like that of a water, nearly neutral molecule, that like a water, so that the reaction takes place in 2 steps. So first step will not be the attack of the halide ion, instead protonation, removal of H plus. Instead, first step will be the removal of bromide ion with the formation of a carbocation. So here also, similar to that of SN1 reaction, the reaction follows the formation of a carbocation. So first step is ionization, and that step will be the slow step, and so it is called as the first order reaction. And the reaction rate depends on the concentration of only the alkyl halide, and in the first step the alkyl halide dissociates, forming a carbocation. Since it is a tertiary carbocation, it is highly stable, and the next step what happens is water attacks, here the base attacks abstracts the H plus from this beta carbon, and then that reaction will be a fast step, and again the same product is formed. Alkene will be the same product, alkene. So E1 reaction also, reaction takes place in 2 steps with the formation of intermediate, while E2 reaction is a concerted reaction involving only the concentration of both alkyl halides and a strong base. So what is our conclusion is, if a strong base is used, the reaction follows E2 mechanism, and if a weak base is used, the reaction follows E1 mechanism. Okay, we'll continue in our next video. We shall see what are the factors affecting these E2 and E1 reactions. Thank you.